we are going to start off with Venn diagrams today. But before we do Venn diagrams, we need to learn a little bit about sets. Okay, so I've got in a hat, there are cards numbered from 1 to 10. The sample space written as a set. Does anyone know how to write the sample space as a set? Anyone want to pop that in the chat? Now, a set just means groupings of stuff. And although we're going to talk like maybe use terms and phrases that are a little bit different, you'll find that you actually know what sets are already, because sets are just groupings of things. And we just write them in a certain way, like we always do in mathematics, like you've got function notation, you've got scientific notation, those things you've already learned. Now there's a bit of set notation, okay? So set notation, yes, Boniwe, well done. Thanks for popping that answer into the chat. So we say that this sample space, we're going to call it S. We're going to give it a name so we know it's this particular one. And we're going to make a curly bracket, and then we're going to put in between those two curly brackets all the cards that are numbered from 1 to 10. So those cards are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. Guys, read the question carefully. In a hat, there are cards numbered from 1 to 10. Okay, we don't stop at 7. Oh, for me, I made a mistake. No problem. Okay, so that is all. And we call these, if you remember from our previous lessons, we call each little object in the sample, we call that an element. Okay, so elements, those are all things I've spoken about in the previous 2 lessons. So you should recognize the word element and sample space as well. Okay, so now from this, we put the cards in the hat, they're numbered from 1 to 10, and now we're going to shake the hat and we are going to start drawing cards. So the first event, remember we said that doing something when we are busy with a probability experiment or something like that, like in this case, drawing cards from a hat, there are certain events. So this event, the first one we're going to look at is the event of drawing a factor of 6. So what are the factors of 6 from the sample space? From the sample space. Okay, Amakle is onto something there. Factors of 6, pop it in the chat, guys. Come on. 2, 3, and 6, says Yenzi. And Simpiwe got it right. And Fumiso and Chloe May, well done. Don't forget about the 1, eh? 1, 2, 3, and 6 all divide into 6. So those are all the factors of 6. So let's be careful when we write this down. That's that event. If I'm going to call it event X, drawing a factor of 6, I'm not calculating probabilities yet. Okay, I'm just listing. I'm just making lists and putting things into sets. So this one is X, 2, 3, and 6. The factors of 6 from this sample space. Remember, I can't go over there to a different sample space. I have to stop at 6. I can only work with what I've got here in my current sample space. It's like that example I used with the clothing. Like if I get dressed in the morning, my sample space or my clothes, I can't go to Miss Coco's cupboard and start putting clothes on from her cupboard, because that is not my sample space. Okay. So now drawing a factor of 9. Drawing a factor of 9, which elements are going to go into that set? 1, 3, and 9. I just again want to talk a little bit about writing it like this. Okay, so that means the probability of the factor of 9. So we're not calculating probabilities yet. We are just listing the things that are going to go into this set, and we've called it Y. Okay, and the first one we called it X. So drawing a factor of 9, that could be 1, 3, and 9. Now, if we look at event X and event Y, those sets that we've listed, do they have anything in common? Are any of the elements both in X and in Y? Okay, nice. 1 and 3, that's right. Okay, 1 and 1 and 3 and 3. And when two events have something in common, or there's overlap between them, we call that the intersection. It's just a big word that we use when we talk about sets and Venn diagrams and probabilities, that the intersection is the elements that are in both X and in Y. And because it's such a long word, and because, you know, mathematicians always like to use symbols for things, there is a symbol for intersection, and it's this one here, the one that looks like an N without the sort of leg, if I can call it that. So intersection is about the word and, meaning overlap. They have something in common, there's intersection, and we use that symbol for it. And the way that you can remember it is, if you look at it, it looks like one of those magnets, right? So think of like one of those magnets, and a magnet, what does a magnet do? It draws things together and it connects things. So if we use that symbol, we're talking about and we are looking at the two events, and I'm just going to change this to X and Y. So the overlap or the intersection between them. So to write that using our correct notation, the intersection between X and Y, if we had to write that as a set, would be 1 and 3. Okay, just put a thumbs up in the chat if you're happy so far with all of that, with and the idea of a set and listing things in sets using curly brackets. If you're not happy, put a thumbs down, but ask a question. Okay, right, now let's read this one carefully, and maybe some of you know it already. Which elements, so if we look at our two sets, X and Y, 1, 2, 3, and 6, and 1, 3, and 9, and which elements are in Y or in X or in both? Who's got the answer for that? Who has read that correctly? Pop your answer in the chat if you know. Now think about it. It can't be the same answer as what we just did, okay? The answer needs to change based on what we are looking at now. We're looking at which elements are in Y or in X or in both. So we said X was 1, 2, 3, and 6. And Y is 1, 3, and 9. Here we go. Chloe May's got it. And Clo's got it. Andrea May, well done, everybody. So if we are looking at which elements are in X or in Y or in both, we're really looking at X or Y or both, and that is everything together. And that is called the union of the two. So if I look at X and Y, then the union includes all the elements of both events, A union B. So for the union, we use the one that looks like a U. Yeah, the one that looks like a U. Or you can think of it, it's like a boat shape, and you need this oar to row your boat. Okay, so that's our symbol for union, and it's all the elements of both events. And you can think of a boat for that because you need the oar. So if we talk about and, that is the intersection, that's the overlap. And if we talk about or, it is everything plus the overlap, everything together. And an or. Right, put an emoji, put a thumbs up in the chat if you're happy with or and understanding what or means. Nice. And if you're not happy, also put that down. You don't have to say you're happy when you're not. Just pop us a question if you are not sure. Okay. Okay, if you didn't get it that first time around, here's another chance. Let's practice again. Guys, if you want to take screenshots, you got to be quick, eh? Unfortunately, there isn't much time to keep going back. Quick screenshot, 1, 2, 3, 4. Okay. If you are saying thumbs down, please pop a question in the chat so that we can know exactly where you okay, so Sinasibo says she didn't understand. Or Ms. Kaka, because you maybe lend a hand there to Sinasibo. But also, let's try it again and let's see, maybe second time around, we can be more comfortable with this idea. Okay. Okay, so pop in the chat. Cards are number 1 to 8 and place in a box. Use set notation to list the sample space S. Pop it in the chat. And guys, I want to see proper set notation. Okay, look at how we did it here with the S equal and then listing it with the curly bracket, everything. I want to see proper set notation. You've got a curly bracket on your keyboard, so now I see S equal, but I see no curly brackets. I want to see some curly. There we go. That's better, Ria. So S equals curly brackets 1, 2, 3, 4, 5, 6, and 7. So that is our sample space. Nice, Notemba. That is on the money. Indepile, nice. Good stuff. Bontle also. Just be careful of using the dots. And Kelly as well. Rather use a semicolon, eh? Use your semicolon. Okay, use set notation. Here's our next one. Now use set notation for the event O of drawing an odd number. Also from our sample space, O is the event of drawing an odd number. Oh, thanks. Orikonisa could be our teaching assistant here, Miss Coco.
Oh no, you can't take my job. No, it's fine. I was gonna tell you.
Oh, you were gonna tell me. Okay, 1, 3, 5, and 7. Nice, that is odd. And now let's do even. Even numbers. Even, easy peasy. E is curly bracket 2, 4, 6, and 8. Nice. Good. And now, well done, Watobians. Everything's looking good. Sorry for the frogs in my throat. Okay, now, next question. Let's see who understood. And I don't know why it says a 1 when it should be a 3. Write the event O, what does that mean? E in set notation. Who can translate that for us into plain English? What is this actually asking for? Is it asking, Boniwe is saying it's or? That's right. On your boat with your oar, and it's making that O union to E. Whew. Yenzi, everyone fancy, very fancy with their nice mathematical language. Write the event O union E in set notation. Okay, so now it's your turn, Watobians. What do we need to write for this? What are we going to write? We've all said it's O or E. So what is it? Pop it in the chat if you know. O or E, what are we going to write? I hope everyone's typing, Miss Coco. Oh, there we go. Nice. That's it. Amachle's got it. Simpiwe. Our other Amachle also, Quirin. Nice. It is, if it's odd or it's even, then it's both. Okay, so then we look at everything that's odd, everything that's even, and we put that together. So it's 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then our last question is write the event O intersection E in set notation. Maybe just reach out to Tandukasi, please, Ms. Coco, and see what does the U mean. It's not a U, it's just like that. And from our previous discussion over here, the U or that symbol means or. So it means odd or even, and that means that it's odd or even, so we take everything together. So Yenzi, I hope you mean in question 4, this means and. So for and, we are looking at the overlap. Or is there anything in O that is also in E? There is no intersection. That's right. No intersection. So there's no intersection, nothing in O that's also in E. So we can be fancy and write it like this. It's an empty set. So we just leave it like that. Literally just an empty set. Okay, good stuff, everybody. Well done. If you are having trouble with something, just pop the question in the chat, or you can DM Ms. Coco as well. That is how you can get your issue sorted. So let's do one more practice round for this. Or actually, never mind. I think you guys actually understand with the sets and stuff. We are going to move on to drawing some Venn diagrams. Okay, so we've got in the sample space whole numbers from 2 to 9 inclusive. In other words, our sample space is 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so event P consists of multiples of 3 in S. So P is that 3, 6, and 9. And then Q are the factors of 6, and it's 2, 3, and 6. Not 1, because 1 is not included in our sample space. And then the multiples of 4 is 4 and 8. So we're going to start off and we are going to draw a Venn diagram for the sample space. So to draw your Venn diagram for your sample space, you just make a rectangle. And in that rectangle goes all the elements of S. So 2, 3, 4, 5, 6, 7, and 8. It's as simple as that. There's your sample space done. Now we can have different events, right? Just like we've had before, drawing different cards, rolling different numbers on a dice. So our first event is event P, getting a 3, 6, or a 9 from our sample space. So now we're going to again go and draw our sample space, but we need to sort of say, over here is an event P, and to do that, we make a circle for P. And we put in that circle all its elements, 3, 6, and 9. 3, 6, and 9, that all forms part of P, but the rest of the numbers are still in the sample space, so we still write them, 2, 4, 5, 7, and 8. Okay, so remember to follow along and to also be drawing this as you take your notes. Okay, I'm going to give you 20 seconds to do the next one on your own. Events P and Q in the sample space S. So P, let me just copy this down. Then you can see what it is. P and Q in the sample space S. Yes, there's our word and. Unfortunately, you guys can't post your Venn diagrams, but you can check that yours is correct. So we go again with our sample space. And now we've got event P. But if you check, there is overlap, there is intersection, 1, 3, and 6. So not 1, just 3 and 6. So when we draw P and Q, we need to show that there's intersection. So we draw them overlapping. And the things that they have in common, we put in that overlap. 3 and 6, 9 is still in P, and 2 is still in Q. Remember to give it a name. And then we still have all the other numbers in the sample space left as well. So we do include them, but we just write them outside of the circles because they don't form part of P or of Q. So 2, 3, 4, 5, 6, 7, and 8. Okay, and then the last one is to do P and R. In the sample, in a Venn diagram. So P we said is 3, 6, and 9. And R is 4 and 8. So again, take 20 seconds to draw yours, and then you can compare it when we are done. Okay, so for R and P, there are no elements in common. So we're not going to show that they overlap because they don't. They've got nothing in common. So it's 3, 6, and 9, and 4, and 8. And we've got 5, 7 and 9. No, 9's already in P. 2, we need 2. There we go. And Shiraz says they are mutually exclusive. Yeah, they are, because they don't overlap. There's nothing, they've got nothing in common. It's like two things that can't happen at the same time. We are going to do mutually exclusive in a lot more detail when next week. Orikinosa, this time I did not leave it out. It is right there above the 7. The 5 is there. Okay. Right. Let's put a thumbs up in the chat. How's everyone doing with our first Venn diagram? Isa, yes? No, Tandalwetu, actually mutually exclusive means no intersection or overlap. Okay. There is nothing that they have in common. They don't overlap. Okay. Now, let's get on top of all this new notation that you need to know for Venn diagrams and for sets and for probability. Okay, so let's get into business with this three circle Venn diagram. Okay, so we've got here event A, event B, event C, and they do overlap, so there is intersection. And we've got these all represent numbers. Okay, so it's the numbers 1 to 11 that's all been put into different groups or events. So this first question asks for n of A. What does it mean? What does n of A mean? N of A. Who knows what that first question actually is asking for? Number of sets, the value of A, found in A, event A. That actually, it simply means number of possible outcomes. Nice, Lutemba, the sample space of A, all on the right track, guys, but it actually just means how many elements are in A. So write that down for yourself if you don't know. So n of A just means how many elements in A. And how many elements have we got in A? Let's highlight it. There's 4. That's right. So A is over here. Okay, so even if it overlaps with something else, with another event, we still count the elements in it. Okay, so 1, 2, 3, 4. Okay. Now the next question asks just for B. Now what is B? That question is actually asking what are the elements of B. Okay, so not how many elements are in B, but what are the elements in B. List the elements of B if you know. 1, 4, 5, and 6. That's it. Yeah, so for question A, we just want to know how many. For question B, they want to know what the elements of B are. And that is 1, 4, 5, and 6. Nice. Okay. Now comes the probability. Probability of C. What is the probability of C? So for this, we need to count all the possibilities in C and divide it by the total number. Nice. Good, guys. That's great. So there are 6 elements in C, and in the total sample, there's 11. So the probability of C is 6 out of 11. Okay, now remember N, this means with your or, okay? This is an or, this looks like the little boat. So we are talking here about A or B. So how many, and it's again asking for N. N always asks for how many. N has to do with how many. So how many elements in A or B? And if we are looking at A or B, then we are looking at A or B. So it's the 2 together with the overlap. So that gives me 1, 2, 3, 4, 5, 6, 7. Okay, careful, we are not working out the probability. We are just saying how many things are in A or in B. And that is 7. Nice. Okay. Let's go to E. You guys are on it this afternoon. Very nice. Let's go to question E. What is the probability of A and C? So here we've got and now we are working out the probability. The probability of A and C. So look where the overlap is. It is not or, so we are only looking at and. For A and for C. That's it, Quirin. I see lots of answers saying 8 out of 11. Think again. We are only looking at the overlap. If we are looking at the overlap, we are looking at this part here for A and C. I think it's time Watobians get some color pencils to help them with this. So it's the 1 and the 8, so that's 2. And there's a total of 11 outcomes, and that's my probability. Okay. Now, C intersection B. So now we're looking at the overlap between C and B. And we're not doing a probability. It's just asking you for C intersection B. So just list the things. Nice, Kutlana. That's good job. Good job, Boniwe. Think again, Tandukasi. Chloe May, well done. Quirin, good job. Great stuff, guys. So if we are just looking and we're not doing a probability, and we're not doing a probability, we are just looking at the overlap between C and B. So that is going to be here. And what are those? That is a 1 and a 5. And guys, remember, there are not eight total things in the sample space. The total sample space consists of 11 elements. Okay, so when we do the probability, it is going to be out of 11. Right, now the last question, let's see who remembers from our previous lesson, not C. Everything that is not C. So to do not, you can just cover C completely with your hand. It's like blacking it out almost. So you can literally go, let's take a dark color and basically block all of C out. We want nothing to do with C. Not C. That is going to be 3, 10, 4, 6. And don't forget the little lonesome 9 over here, hey? There's a 9 there. Okay, so not C is 3, 4, 6, 9, and 10. Good job, everybody. Nice. 3, 4, 6, 9, and 10. Excellent. Good. I think that was a job well done. Let's move on to some proper, let me see. We can do that. Let's do this. Okay, I'm going to give you about a minute. Just find your answers and hold them. Don't put them down yet. Okay, pop your answers in the chat. How many people enjoy both coffee and tea? Yes, that, if we put it into our nice probability language, that is the intersection. Both coffee and tea is 17. How many people enjoy coffee but not tea? Coffee but not tea. So coffee only. Nice. That's 38. And then how many people liked neither coffee nor tea? Look at the answers flowing in. Nice. 22.
You guys are so fast. Yo, guys.
You're super fast. Okay, next one. In a class of 32 students, 18 study French, 21 study Spanish, and 4 study neither. Okay, so represent this in a Venn diagram. We've started you off there with a Venn diagram. And so you can just finish it. And then a student is selected at random. Find the probability that the student studies only French. Okay. So over to you, your turn. 1 minute. 1 minute? Yeah, I think 1 minute's fine. Okay, so this was maybe a little bit of a challenge here at the end. So let's see what you guys all did. Okay. So we need to think about a bit about this carefully because we have a class of 32 students. And if you look at the 18 and the 21, that adds up to more than 32. That actually gives you 18 plus 21 is 39. So yeah, 18 is 39. And you have the 4 students who study neither. So we can put those 4 outside of the circle. So that means the French and the Spanish students together must make 28. So how are we going to figure out what the sort of overlap is? Those that actually do it together, do both, because it doesn't give us that information. Yes, Oriconisa, sorry.
Hi, ma'am.
Yes. Yeah, go ahead.
So what we're going to do here, we're going to see 8 plus 4 plus x equals to 32. Take our values to the other side and say 32 minus 18 minus 21 minus 4, which is going to give us, and then we're going to put our 11, and then we're going to.
Sorry, I can't hear you, Oriconisa. I can't hear you. I can't.
Positive, and we're going to say x in Spanish. We're going to say 18.
Yeah, I can't hear you. Sorry. Yeah, Muskaka, I don't know. I can't hear Oriconisa. Yeah, the network is quite bad. Okay. Yeah, sorry about that. So I think what we're going to have to do here is, first of all, figure out what the overlap is. And we're going to make that an unknown. So someone's saying 7 out of 32, but let's see, there's another answer in the chat. 7. Yeah, guys, it's not 7. I'm not sure how you guys are getting 7. Corinne, do you maybe want to tell us how you get 7? Because we don't know how many students take both, but we do know that all of them together must add up to 32. So 39 minus 28 is 11. 39 minus 28 is 11. I think that's the right answer. That is right. So we're going to go the 39 minus 11. 11 take both. I agree with that. 11 take both. And we can do it without actually going down the route of solving for x, etc. So that means 7 take French and 10 take Spanish. How do we get the 11? Because if you look at the number that's given, the 38 plus the 21 together gives you 39. And then you subtract from it the 28. So that's the double counting. It's the counting those that do both. Okay, so 39 minus 28, that gives me the 11 that go in the middle. And then the probability of finding, of a student taking only French, that is 7 out of the 32. So I see a few people got the 7 out of 32. And then Amachli is also saying 28 minus 18 is 10 French. Yes, you can do it that way as well. If you go 28 minus 18. Yeah, okay. But we'll do more